Class, this is part 2 to discuss Boolean expressions. In part 1, I told you that a Boolean expression is an expression that gives a result of either true or false. And we talked about relational operators. There's 6 relational operators that can be used to generate those type of expressions. You have less than or equal to, greater than or equal to, equal, remember it's double equal, and not equal. And so now we want to discuss logical operators that can be used to connect two or more relational expressions together. There are 3 logical operators, not, and or. And this says Java, but these are also what they are, how they are coded in C++. Not is the exclamation point, and is the double ampersand, and or is 2 of the straight line character, which is the shift of the slash that's above the enter key. So, logical operators only work on true or false data. And so there's only 4 possible combinations of putting true and false together. Here's the way to think about the and. These are called truth tables because this is basically the definition of the and function, the or function, and the not function. The AND function requires both things to be true in order to get a true result. So if I tell you go to McDonald's and bring me back a hamburger and French fries, then the only way that I am happy is if you bring me both. If you bring me back just a hamburger, no fries, no hamburger or fries, or neither, then I'm not happy. So AND requires both expressions to be true. Or is not the opposite of and. Or means if either or both are true, then it's okay. So if I tell you bring me back a burger or French fries, then there's 3 ways to make me happy. If you bring me back a burger and French fries, just a burger, just a French fries, then you'll be fine. The only way that an or is false is if both sides are false. And the only way that an and is true is if both sides are true. And so that's the best way to think about that. Not just reverses the operation. So not true is false, not false is true. Now we have the possibility of having arithmetic, relational, and logical operators. And so how do we sort out that? Well, you start with your arithmetic, and you follow order of operations. Well, you always do parentheses first, and if you have a negative or a not, that goes first. Then you do your arithmetic, you do your relational operators, and you do your logical operators. So here is a big long expression that has all 3 of them. Remember, arithmetic first, then relational, then logical. So if we sort this out step by step, we have to do all the arithmetic. Within the arithmetic, you have to follow order of operations. And so here, for example, I've got to do the multiplication first. So that's 12. So over here, this side ends up being 2 plus 12, which is 14. I have to do the parentheses here. Then I have to do this division before addition. And so this ends up being 7. Here, we do this division, we get 5. We do this addition, we get 5. And so when all the arithmetic is gone, I am left with, here's a relational operator, here's a relational operator, here's a logical operator. The next one that we do are relational. So that means we do this, 14 less than 7. That is false. Then we do the other relational operator, is 5 greater than or equal to 5. That is true. So now all I have left is the logical operator, and false or true gives me true. Because remember, if it's an or, then any true makes an or true. Right? Now, here are some examples just to kind of walk you through and understand it. So now, I have to compare numbers to numbers. I have to compare letters to letters. I cannot, for example, say, is red greater than 22? I don't know. We don't have a way of doing that. And so we don't compare different data types. However, we can combine expressions using logical operators. So let's just look at these real quick. So here's capital A greater than capital B. Well, that's false, remember, because A comes before B, that means A is less than B. So A greater than B is false. Not false gives me true. And so that's why the result of this is true. You always start inside the parentheses. So is 6 less than or equal to 7? That's true. And so you have not true, which is false, right? Here I have two separate relational expressions combined by a logical operator. So is 14 greater than or equal to 5? That's true. Is A less than B? That's true. So I have true and true, which gives me true as a result. Is 24 greater than or equal to 35? That's false. Now, if that's false and this is an and, do I even need to look at the other side? I don't, because there's no possibility for this to be true. Remember, the and operator requires both sides to be true. So without even evaluating the other side, I know that this is false. Here I have A greater than B. So that is false. Remember, A is less than B. However, this is an or, and so there's still a chance that it could be true. We have to check the other side. Is 6 greater than 7? That is false, and so the entire expression is false. Here, we've got 17 greater than 10. That is true, and because this is an or, it doesn't even matter what the other side, true or anything, gives me true, and so the result of this is true. So there we have evaluating logical operators and relational operators. Again, quick review. There are 6 logical operators. We've got less than or equal to, greater than or equal to, equal, and not equal. We have 3 logical operators, not, and or. And we will discover that selection statements are based on a Boolean expression. And so this is why we have to understand relational and logical operators first before we move on to selection statement.